In number 57, we are told that there's 9 pieces of candy on a plate, and 2 kids are going to select some of them. Mo is going to choose first, and he can select 2. Then Joe's going to choose second, and he can select 3. And what we want to know is, apparently Joe is complaining that he has fewer options than Mo, and we want to know if Joe is correct. So let's count the number of ways that each one of these kids can select their candies. So Mo, he has select first. So he can take, out of 9, he can take any 2. Now, when I compute a combination of 9 choose 2, I got 36. And Joe, he's got only 7 candies to choose from, right? Because Mo took 2, so there's only 7 left. And he can choose 3. And when I computed that one, I got 35. So it looks like Joe is correct, that Mo has more options than does Joe. In problem 61, we want to know how many ways can 5 mathematics books and 4 novels be placed on a bookshelf if the mathematics books must be placed together. I'm going to look at this problem this way. There's 9 slots, 9 places on this bookshelf for these books. 4, 5, 6, 7, 8, 9. Now, I want these math books to be together, so they can't just be anywhere. They need to be together. So here's where they could be, right? They could be 1, 2, 3, 4, 5. We could have the 5 math books here, or we could have the 5 math books in this position here, starting with the second slot. We could have the 5 math books placed here, or we could have those 5 mathematics books here, or finally, they could be here in those last 5 positions. So the first decision I think we have to make is, in which one of these positions here, do we have to place the math books? Well, it looks like there's 1, 2, 3, 4, 5 ways we can make that decision. So I think our first decision is, which position do we want those math books? I think there's 5 ways that we can make that decision. Then once we select a position, like suppose we select this first 5 position, then we've got these 5 books. The next decision is, how do we want to arrange them? Like book A, B, C, D, E, or D, E, A, C, F, whatever. We're going to have, how many ways can we make that decision? Well, there's 5 books. We want to arrange them. There's 5 factorial ways to make that decision. Then the remaining books are those 4 novels, and the 4 novels can go in any one of the remaining 4 positions, but we can arrange them in 4 factorial different ways. So when I computed this, I got the number 14,400. So just to summarize here, this 5 right here, that is the number of ways that we can put the math books all together, right? We could put them in the first 5 position, the second 5 positions, the third, the fourth, the 5th positions. That's our first decision, is where do we want to put those math books? I've got 5 ways to do it. Then once I get the math position, the books in that position, I've got 5 factorial ways I can arrange them, right? The first math, the second math, the third, the fourth, and the 5th. 5 books on the left to choose from, 4, and then 3, 2, and 1. And then I've got the novels, and there's 4 factorial ways to order those novels.